The main water source for the Kaohsiung area comes from the Gaoping River weir, supplemented by the Qinxing Lake Reservoir, Agongdian Reservoir, Fengshan Reservoir, and Nanhua Reservoir in Tainan. These sources provide water to the Qinxing Lake Water Purification Station, Luzhu Water Purification Station, Fengshan Water Purification Station, Pingding Water Purification Station, Wongongyuan Water Purification Station, and Kaotan Water Purification Station. The Gaoping River can supply water up to 2 million cubic meters per day, providing raw water to the Pingding, Wongongyuan, Kaotan, and Qinxing Lake Purification Stations, making it the primary source of public water in the Kaohsiung area. Due to the significant difference in rainfall between the wet and dry seasons in southern Taiwan, the Nanhua Reservoir and Gaoping River interconnecting pipeline was constructed in 2001 to stabilize water supply from the Gaoping River weir. It was completed in 2003, with a designed daily supply capacity of 800,000 cubic meters. The main water sources for the Pingdung area come from the Mudan Reservoir and groundwater. The Mudan Water Purification Station supplies water to the southern Pingdung area, while the Pingdung Water Purification Station supplies the northern part of the area. The previous chapter introduced the Qinxing Lake Reservoir and Qinxing Lake Water Purification Station, Agongdian Reservoir and Luzhu Water Purification Station, Fengshan Reservoir, and Fengshan Water Purification Station. This chapter will continue by discussing the Gaoping River weir, Pingding Water Purification Station, Wongongyuan Water Purification Station, Kaotan Water Purification Station, and the Mudan Reservoir, Mudan Water Purification Station, and Pingdung Water Purification Station in the Pingdung area. The water sources for Pingding, Wongongyuan, and Kaotan Water Purification Stations primarily come from the Gaoping River weir. Also known as the Dashu weir, it is located in Dashu district of Kaohsiung City, 2 kilometers upstream of the Gaoping Railway Bridge on the lower reaches of the Gaoping River. The Gaoping River weir was constructed to address the significant difference in rainfall between the wet and dry seasons in southern Taiwan. To stabilize the regional water supply, construction began in 1994 and was completed in 1999, making it an important water resource project in southern Taiwan, following the Nanhua and Mudan reservoirs. The water intake point for the Gaoping River weir is upstream of the confluence of the Wulua River and Gaoping River. The weir can supply water year-round, with an initial supply capacity of 1 million cubic meters per day and a maximum supply capacity of 2 million cubic meters per day, making it the primary source of public water supply in the Kaohsiung area. The functions of the weir include reducing groundwater extraction in the Kaohsiung-Pingtung area, mitigating land subsidence, and resolving local water rights disputes. Additionally, it is connected to the Nanhua Reservoir via an interconnecting pipeline, allowing for joint water supply, further stabilizing the provision of municipal and industrial water for the Kaohsiung area. The Gaoping River weir is Taiwan's first rubber dam weir and remains the widest rubber dam weir in the country. It is designed to raise the water level but has no water storage function. The intake level is set at an elevation of 16.4 meters, with a designed water intake capacity of 35 cubic meters per second. The weir structure is 960 meters long, divided into a 286-meter movable weir section and a 674-meter fixed weir section. The movable weir is equipped with inflatable rubber dams, consisting of a total of 8 rubber dams. The fixed weir is a concrete structure, 674 meters in length. There are 3 bed protection structures, each 45 meters wide, spaced 100 meters apart. The water intake point is designed to handle 35 cubic meters per second and includes 14 sluice gates. The water abstraction work is designed to handle 35 cubic meters per second and features 3 water control gates, followed by a grit chamber. The discharge channel has a maximum discharge capacity of 37 cubic meters per second and features 3 water control gates. It discharges turbid water back into the Gaoping River. Inflatable rubber dams are characterized by their low construction cost, ability to avoid blocking water, leak resistance, high seismic resilience, low foundation requirements, and short construction period. The dams can automatically fold down to release floodwaters, preventing upstream water levels from rising too high and causing flooding. However, they are more prone to damage and wear, resulting in a shorter lifespan compared to concrete weirs. In 2009, Typhoon Morakot brought torrential rains to the Kaohsiung River basin, submerging the Kaohsiung River weir. Both the interior and exterior of the weir were severely silted and clogged with driftwood. Among the 8 rubber dams, 3 were punctured by driftwood and were replaced in early 2010. After the completion of the Nan Hua Reservoir, in addition to supplying raw water to the Nan Hua Water Purification Station, an interconnecting pipeline with the Kaohsiung River weir was constructed to stabilize its water supply. During the wet season, water is diverted from the Jiaxian weir to fill the Nan Hua Reservoir. When the Kaohsiung River weir's supply is insufficient, water is transferred from the Nan Hua Reservoir. The Nan-Hua-Kaohsiung interconnecting pipeline, completed in 2003, is 57.7 kilometers long, with a total supply capacity of 800,000 cubic meters per day. It was built to address water shortages during the Kaohsiung River's dry season. The pipeline operates entirely by gravity, making it an energy-efficient water resource facility. In 2006, additional lining was installed in parts of the pipeline, and 3 pressure-reducing stations were added along the route. These upgrades were completed in March 2007, significantly improving the region's capacity to respond to water shortages. Pingtung Water Purification Station, located in Dashu Township, was originally constructed in 1909. Its predecessor was a water purification station established during the Japanese colonial period in Xiaoping Village, serving as Kaohsiung's first headwater point. Initially, the station had a water output of 140,000 cubic meters per day. In 1999, the first phase of an expansion project was completed, increasing the designed output to 800,000 cubic meters per day. The station has 2 main sources of raw water. The first is surface water drawn from the Kaohsiung River weir, with an average intake of 520,000 cubic meters per day, and the second is groundwater extracted from the Julia Water Station, with an extraction volume of 30,000 cubic meters per day. Additionally, the Nan Hua Reservoir serves as a backup water source. Currently, the Pingtung Water Purification Station has a water output of 560,000 cubic meters per day, which can supply approximately 1.2 million residents. The water purification facilities at Pingtung Water Purification Station include a distribution well, flash mixer, flocculation clarifier, rapid sand filter, clear water reservoir, wastewater basin, sludge thickener, and sludge detention tank. The water purification process at Pingtung Water Purification Station involves drawing raw water from the Kaohsiung River weir and the Julia Water Station, which is then sent to the distribution well. The water is subsequently distributed to various flash mixers, passes through the flocculation clarifier, rapid sand filter, and chlorine disinfection system before being stored in the clear water reservoir. Finally, the purified water is distributed to different areas in Kaohsiung for residential use. The main water supply areas for Pingtung Water Purification Station include Nanzi District, Zhuiying District, and Northern Kaohsiung, as well as Dashu, Ranwu, Dash, Gangshan, and Fengshan districts in Kaohsiung City. Wongongyuan Water Purification Station was constructed in 1938 and originally served as Kaohsiung's second headwater point. Its water supply involved drawing subsurface water from the Kaohsiung River and pumping it into shallow wells at the station. The initial design had a daily output of 8,350 cubic meters, sufficient to supply 50,000 residents. After being taken over by the Kaohsiung city government in 1945, the station underwent expansions and improvements, increasing its output to 15,000 cubic meters per day. In 1970, 4 new rapid sand filters were built, and deep wells were drilled along the banks of the Kaohsiung River to replace the old wells, increasing the total output to 25,000 cubic meters per day, bringing the combined output to 40,000 cubic meters per day. In 1996, Wongongyuan Water Purification Station was merged with Kaohsiung Water Purification Station for unified management. Due to aging wells and difficulty in finding new ones, the water source was switched to surface water from the Kaoping River weir, while groundwater became a supplementary source. Some of the raw water drawn was sent to Kaohsiung Water Purification Station for further treatment. In 2007, advanced water treatment equipment was added to improve drinking water quality, with an output of 30,000 cubic meters per day. The water purification facilities at Wongongyuan Water Purification Station include a grit removal tank, powdered activated carbon equipment, flash mixer, flocculation basin, rapid sedimentation tank, regulation basin, rapid sand filter, UF feed tank, UF product tank, clear water reservoir, sludge thickener, wastewater basin, and aeration tower. The water purification process at Wongongyuan Water Purification Station starts by drawing raw water from the Kaoping River weir into the grit removal tank. The water is treated through a series of facilities, including the flash mixer, flocculation basin, rapid sedimentation tank, regulation basin, and rapid sand filter. It then passes through advanced purification units like UF and LPRO to improve water quality. The purified water is stored in the clear water reservoir before being distributed to the city for residential use. The main water supply areas for Wongongyuan Water Purification Station include Fengshan District and Daliao District. Kaohsiung Water Purification Station is located in Daliao Township and was constructed in 1972. The original water source was deep wells in the Daliao area. Initially under the jurisdiction of the Qinqing Lake Industrial Water Treatment Plant, the station had a designed output of 152,000 cubic meters per day, primarily supplying the Kaohsiung Linhai Industrial Park. In 1974, it was merged with the Water Corporation and redesignated as Kaohsiung Water Treatment Plant. In 1993, in line with the Water Corporation's policy of separating industrial and residential water supplies, additional facilities, including rapid sand filters, clear water reservoirs, and flocculation clarifiers, were constructed in 1995, increasing the output by 100,000 cubic meters per day, bringing the total designed output to 252,000 cubic meters per day. However, long-term extraction from deep wells led to a decline in groundwater levels. In 1996, Wongongyuan Water Purification Station was merged into Kaohsiung Water Purification Station, and the water source was shifted to surface water from the Kaoping River weir, transferred via a regulation basin to Kaohsiung Water Purification Station, with deep wells in the Nanhua Reservoir serving as backup sources. In 2007, advanced water treatment equipment was installed, and the current designed output is 225,000 cubic meters per day, with a maximum capacity of 270,000 cubic meters per day, supplying water to over 540,000 residents. The water purification process at Kaohsiung Water Purification Station involves receiving raw water from Wongongyuan Water Purification Station. The raw water is first treated in a flocculation clarifier. Another water source, drawn from deep wells, is processed in a distribution well and aeration tower before entering the coagulation basin and rapid sand filters. The water is then sent to the UF unit system for particle removal and the LPRO system for ammonia-nitrogen removal. After filtration through both systems, the water re-enters the coagulation basin, and the treated water is stored in the clear water reservoir before being distributed to urban areas for residential use. The main supply areas for Kaohsiung Water Purification Station include Saigang, Sijin, Xianjin, Linyuan, Daliao, and Fengshan districts in Kaohsiung City. Mudan Reservoir serves as the primary water source for Mudan Water Purification Station. It is located in the valley of Sikhong River in Mudan Township, southern Pingtung County, and was completed at the end of 1995. Mudan Reservoir collects water from the upstream tributaries of Mudan River and Ruring River, primarily supplying the area from Donggang to the Hangchuan Peninsula. The reservoir has a capacity of 39.4 million cubic meters and irrigates an area of 500 hectares, supplying raw water to Mudan Water Purification Station with 100,000 cubic meters per day. The facilities at Mudan Reservoir include a zoned rolled fill embankment dam. The spillway is a gated controlled overflow work connected to a discharge chute, while the intake works consist of an inclined multi-level intake tower located on the right bank of the dam, which connects to a water tunnel. The grandeur of the Mudan Reservoir spillway gates is impressive. Walking along the top of the dam offers sweeping views of Sherman Village. From a distance, the entire reservoir reflects white clouds and green mountains on its calm waters, creating a stunning landscape. Mudan Water Purification Station is located in Mudan Township, Pingtung County, and sources its water from Mudan Reservoir. It has a designed output of 100,000 cubic meters per day, primarily supplying the southern Pingtung area. The water purification facilities at Mudan Water Purification Station include a distribution well, flocculation basin, sedimentation tank, rapid sand filter, clear water reservoir, wastewater basin, sludge thickener, and sludge drying field. The water purification process at Mudan Water Purification Station involves pressurizing raw water from Mudan Reservoir and sending it to the distribution well. After undergoing flocculation, sedimentation, and rapid filtration, the water is sent to the clear water reservoir. It is then distributed by gravity through two lines, one to the north and one to the south, to supply water to residential areas. The water supply area of Mudan Water Purification Station includes 17 townships: Mudan, Hangchuan, Manzhou, Chaicheng, Fenggang, Fangsun, Shizhi, Chuanri, Fangliao, Xinpi, Kanding, Nanzhou, Jiadong, Linbian, Donggang, Sinyuan, and Xialuqiu. The pipeline network extends over 149 kilometers. The predecessor of the Pingtung Water Purification Station was the Agu Waterworks, built during the Japanese colonial period. Water supply began in 1916, and as Pingtung City's population grew, the original waterworks could no longer meet the demand. In 1934, a new water source was developed in Changxing, and the facility was expanded in 1938. Due to the abundance of groundwater in Pingtung City, the main water source for the Pingtung Water Purification Station comes from deep wells, with an output of approximately 65,000 cubic meters per day, supplying water to around 63,000 residents in Pingtung City. The water purification facilities at Pingtung Water Purification Station include aeration sedimentation tanks, slow sand filters, rapid sand filters, and a clear water reservoir. The water purification process at Pingtung Water Purification Station involves extracting raw water from deep wells within the facility and sending it to the aeration sedimentation tank. The water then undergoes sedimentation, filtration, and rapid filtration before being stored in the clear water reservoir and distributed to the city for residential use. The main water supply areas for Pingtung Water Purification Station include Pingtung City, Changji Township, and Wandan Township. During the Japanese colonial period, several water supply systems were established in the Kaohsiung-Pingtung area, including the Kaohsiung Water Source, Sison Waterworks, Fengshan Waterworks, Gangshan Waterworks, and Agu Waterworks. However, with the rapid population growth and industrial development in the area, the original waterworks became insufficient. After World War II, the water systems from the Japanese colonial period were expanded into facilities like the Pingtung Water Purification Station, Wongongyuan Water Purification Station, and Pingtung Water Purification Station. Additionally, new purification stations were constructed, including Kaotan Water Purification Station, Chenxing Lake Water Purification Station, Fangshan Water Purification Station, Luju Water Purification Station, and Mudan Water Purification Station. In terms of water sources, several reservoirs were successively built, including Chinching Lake Reservoir, Agongdian Reservoir, Fengshan Reservoir, Mudan Reservoir, Gaoping River Weir, and the Nanhua Reservoir interconnecting pipeline, to ensure a more stable and adequate water supply. The waterworks in the Kaohsiung-Pingtung area have spanned over a century, contributing to the industrial growth and economic prosperity of the area. As we enjoy the conveniences of modern life, let us not forget to appreciate the long-standing efforts and dedication of the public water supply personnel.